In this video, we'll look at how to factor a difference of squares. So first of all, we can tell that it's a difference of squares, and this is really important. If it's a difference, that implies that the operation between the two terms needs to be a minus sign. So that's an indication that it's a difference. And it's a difference of squares because each one of the terms, the first term and the second term, can be written as perfect squares. So for example, we could rewrite 25x squared by taking the square root of that whole term, rewrite that as 5x all squared. So if I take 5x and square it, 5x times 5x would be 25x squared. And then I can also write 4 as a perfect square, so that's just 2 squared. So now we can see that we have a difference with the minus sign, and that difference is of 2 squares. And when we factor a difference of squares, we factor it as a 2 binomials. It'll factor to 2 binomials. The first term here will be a 5x, and the first term in the next set of brackets will be a 5x to give us our 25x squared, right? So we're taking our 5x, we're multiplying it by itself when we do the expansion to get that 25x squared. Let's backtrack a little bit. There we go. And then we also do the same thing with the 2 here. We're going to put the 2 at the back end of each one of these sets of brackets so that we can get our 2 squared. 2 times 2 is 2 squared. But in order to get a minus sign here, one of these is going to have to be a positive and one is going to have to be a negative. So when we multiply 2 by negative 2, we will in fact get negative 2 squared or negative 4. And we can check our answer. So this is the answer as factored, as factoring this difference of squares. 25x squared minus 4 gives us 5x plus 2 times 5x minus 2. And we can check our answer. You don't have to do this every time, but just so we can verify that we're on the right path here. We can just double check and go ahead and do the expansion. So 5x plus 2 times 5x minus 2. We'll just make sure that we get the same thing that we started with back. That's the nice thing about factoring and expanding. You can kind of check. So let's go ahead and multiply 5x by 5x. That gives us 25x squared. We multiply 5x by negative 2. That's going to give us a negative 10x. And some of you might get a little worried here saying, oh, we don't have any x terms. What's going on? But here, when we take the 2 and multiply it by the 5x, we'll get a positive 10x. And then finally, 2 times negative 2 will give us that negative 4 that we started with. And the reason why we need a positive and a negative, a plus sign in one set of brackets and a minus sign in the other set of brackets is so that these two terms here will add to 0 or kind of undo each other. So we have a negative 10x plus 10x. That gives us 0. So now we can write this as 25x squared. The 0 here, the x's are gone, and we're left with a negative 4. So we have, in fact, factored this correctly. And generally speaking, when we factor a difference of squares, just write this down, generally. See if I can fix that. There we go. Generally, if we're factoring a difference of squares, so ax all squared minus b squared, and again, it is important that that is a minus sign. That's where the difference comes from. That's going to factor into ax in the first set of brackets, ax in the second set of brackets, and in the second, at the end of each set of brackets, we'll have a positive b in one and a negative b in the other brackets. And that's how we can factor a difference of squares.